Step inside the evidence room. Pull up a chair. Right now, the desk lamp is casting a pretty stark light across an absolute mountain of past papers. And we all know the clock is ticking down to your exam date. Welcome to the forensic files of Cambridge AS and A-Level Mathematics 9709. I'm your lead detective today, and we are investigating a highly volatile, high-stakes profile, 3.1 algebra. Specifically, we're looking at modulus functions. Listen closely, because I'm going to read you the defining statement of today's case. Quote, "The difference between a B and an A star in mathematics often comes down to how well you understand 3.1 algebra, modulus functions. It is literally the ultimate separator." Today, we are cracking open the examiner's private playbook to investigate exactly how you can secure a perfect 100% case resolution score. We aren't just looking for the right answers here. We're hunting for the exact forensic evidence the examiners demand to see.
Our mission in this explainer is absolute, crystal clarity. We're here to launch you into a true modulus functions masterclass. To do that, we need to completely demystify the examiner's mindset. You see, the principal examiners, they are essentially the judges in our courtroom. They actually do not care solely about your final answer. The final answer is just the end of the line. What they really care about is the investigative trail you follow to get there. They want to see your method. They are desperately looking to award maximum method marks, but they will only do so if your forensic evidence is airtight. If there's a gap in your logic, the case gets thrown out. If you want to clear your upcoming Cambridge sessions, you have to understand exactly how the judges evaluate your evidence on the stand.
Okay, let's dive into this. Here is our structured investigative roadmap for the case today. First, we'll uncover the A-level math trap. Second, we'll break down the core principles of modulus. Third, we'll map out the method mark strategy. And finally, number 4, examiner insights and evaluation. Let's begin the forensic deconstruction. Phase 1 of our investigation. Section 1, the A-level math trap, missing the bigger picture. Let's look at why so many students fall right into this snare.
To really understand this trap, I want you to consider 2 junior detectives I work with on these math cases. We'll call them Agent Alex and Agent Sam. Now, Agent Alex is a procedural detective. Alex gathers vast mountains of physical evidence, memorizes all the textbook facts, and writes out huge definitions, but totally fails to build a coherent case motive. Alex lacks the high-level analysis to tie the facts to the specific crime scene. On the other hand, we have Agent Sam. Sam is fast. Sam is a maverick who jumps to immediate conclusions, skipping vital forensic confirmation steps. Sam will look at a modulus bracket and just instantly square both sides to get rid of it, completely missing the vital command word constraints and generating phantom solutions. To avoid their fate, you have to master the theoretical architecture of the syllabus. The foundation relies on 3 massive pillars: precise definitions, causal relationships, and cross-topic integration. If you fail to connect the modulus equation to its graphical V-shape representation, or if you can't integrate it with quadratic inequalities, you are leaving fingerprints of sheer incompetence all over your exam paper. Examiners explicitly reward this structural understanding. They want to see the red yarn on the evidence board connecting 3.1 algebra to the rest of the syllabus.
That brings us to Section 2, the core principles of modulus, specifically focusing on the cognitive domains. The Cambridge assessment framework doesn't just ask you to solve things blindly. It operates on a highly exact hierarchy of cognitive domains. Let's break these down. Knowledge and understanding is your baseline. This is knowing that the modulus, or absolute value, of a number is its non-negative value. It's the most basic physical evidence. Then we move up to application. That's using this knowledge in context, like setting up the 2 distinct pathways for an absolute value equation. But the highest tier, the cognitive tier that literally separates the standard B grade from the elite A star, is analysis. You must deconstruct the given evidence, break it into logical steps, and actively evaluate the alternatives to build a bulletproof case. Junior Agent Alex gets completely stuck at knowledge. Agent Sam tries to leap straight to application, but entirely skips analysis. You, as the lead detective of your own exam paper, must master all 3 simultaneously. So, the crucial point is this. Academic benchmarks prioritize analytical depth over superficial breadth. I really want to let that sink in for a second. The examiners are explicitly warning you against a shallow spread of information. They demand logical, structured reasoning,
Think about it. If you have a massive 6-mark modulus function question pinned to the center of your desk, just writing down 6 different unconnected equations is going to get you absolutely nowhere. You need depth. You need to show that you have fully interrogated the mathematical evidence, understood the constraints of the domain, and formulated a deep analytical logic string. Superficial breadth is basically a misdemeanor in the exam hall. Analytical depth is what actually wins the case and secures the high-tier marking bands.
Let's move into Section 3, where we shift from theory to execution. The method mark strategy, procedural perfection.
Listen, I was watching Alex and Sam at the evidence table earlier today trying to stitch together a model response for a brutal modulus inequality. It was chaos. Alex was slamming his hand down, arguing to overload the text block with long blocks of textbook definitions about critical values. Sam was fighting him, wanting to just build a direct analytical logic string, square both sides, and jump to the final band before the clock ran out. They were rewriting their thesis lines multiple times live, and honestly, they were both missing the mark. I had to step in and give them the primary 3-step DSE problem-solving matrix required for modulus functions. Step 1. Deconstruct. You have to identify the given information and break it into logical steps. What exactly is the domain? What are the specific constraints of the graph? Step 2. Solve. You solve systematically using a carefully selected analytical framework. Are you splitting it into positive and negative cases, or are you squaring it? You have to choose wisely. And Step 3. The one everyone, including Sam, misses. Evaluate. You must check for reasonableness. Did squaring both sides introduce an extraneous root, an impossible suspect? If you don't cross-examine and evaluate your own solutions, your method marks completely collapse.
Case file freeze. Before we revealed the ultimate standardized procedural sequence to help you clear your upcoming Cambridge sessions, we need to make sure your intelligence feed is completely secure. Take a second right now to subscribe to Ace the Exams at the handle @Ace the Exams, and turn on all notifications so you never miss our weekly forensic exam updates, whether you are cracking cases at IGCSE, O-levels, AS, or A-levels. Okay, back to the case. To ensure your method marks stay totally intact, there is a strict, standardized procedural sequence expected by the examiners. It's a 5-step protocol. Identify key elements, apply relevant principles, execute clear working, verify results, present in appropriate format. This is where the PEEL matrix comes in. Point, evidence, explain, link. You anchor your data to your analysis flawlessly. Presentation conventions in 3.1 algebra are strictly non-negotiable. Proper headings, correct mathematical terminology, clear annotation, these are the absolute lifeblood of your defense. If you execute sloppy working, your analytical logic string breaks. If you fail to verify your results, your evidence is inadmissible in court.
Welcome to Section 4, Examiner Insights and Evaluation, the autopsy of mistakes. This is where we look at the cold, hard facts of where past candidates have met their demise. As your lead detective, I have exclusive access to the principal examiner reports. Think of these as the insider documents from the chief of police detailing exactly where candidates perish year after year. Here are the top 3 examiner warnings extracted directly from those files. Warning number 1, wrong approach for the wrong context. This is the classic trap. Trying to apply a linear solution to a nonlinear modulus constraint is a fatal forensic error that instantly destroys your mark integrity. Warning number 2, ignoring format and presentation. A brilliant mathematical deduction presented sloppily simply will not stand up under cross-examination. Warning number 3, providing generic, non-specific answers. Writing out basic textbook facts that aren't linked to the specific scenario is a guaranteed failure point. If you are given a complex source data chart with unique coordinates, a generic statement about modulus graphs yields literally 0 marks. I'm handing the investigation files over to you for a live forensic check. Let's do a visual scan. Look at the comparison on screen. I want you to identify the counterfeit answer. We have the average candidate on the left and the top scoring candidate on the right. You have 60 seconds in your mind to extract the core trend. Ready? On the left side, we have the counterfeit. Generic descriptive statements with 0 context. This is the absolute fluff that Agent Alex writes. It's true information, but it solves nothing. 0 analytical method marks. Now look at the right side. Evaluative arguments with specific contextual links. This is the hallmark of the elite investigator. If you can locate the exact sentence where false logic or descriptive fluff destroys the mark integrity on the left, you can cross it out, replace it with a specific contextual link, and elevate that answer directly into the A-star band. And this brilliantly illustrates what the examiners demand, a flawless, balanced block of text that proves you understand the context.
To consistently hit that top band, you need evaluative thinking mastery.
The higher-order assessment objectives demand that you constantly evaluate limitations, question initial assumptions, consider different perspectives, and justify your decisions with hard mathematical evidence. If you are solving a modulus function, interrogate it. Ask yourself, what assumptions am I making about this domain? Are there alternative interpretations of this graph? What are the limitations of the algebraic method I literally just selected? Remember the PEL matrix. Point, evidence, explain, link. You don't just state a route and walk away from the crime scene. You justify exactly why that route is valid within the strict parameters of the modulus definition, and you link it back to the core question. That is how you secure a conviction.
So, I have to challenge you directly right now. Are you losing marks to the classic trap? I want you to audit your own exam strategies today. Dig out your last math mock exam and look at the red ink. Did you lose marks because you legitimately didn't know the math, or because your modulus function answers lacked specific contextual links? Did you jump to immediate conclusions like Agent Sam, or write generic, unhelpful statements like Agent Alex? If your answers are not heavily integrated with the specific context of the question, you are bleeding method marks. You are leaving the scene of the crime contaminated, and the judges will penalize you for it.
We're closing the file on this one. To keep your case resolution score at a perfect 100%, you need to memorize the ultimate checklist. Rule number 1, the 3-step question scan. Deconstruct accurately. Decode the command words and the exact context before you write a single number. Rule number 2, allocate your clock budget. Timing is everything. Do not spend 10 minutes writing generic statements that yield 0 marks. Rule number 3, the final evidence audit. Review your final answer against the required procedural framework to ensure you haven't left any extraneous, impossible routes masquerading as solutions. The procedural frameworks we have uncovered today are your absolute ultimate defense in the exam hall. But before we completely lock down this case file, make sure you are subscribed to Ace the Exams at the handle @AceTheExams. Click that notification bell for our weekly grade masterclasses and drop a comment below sharing exactly which Cambridge subject and level, IGCSE, O, AS, or A-level, you are preparing to conquer next. So the next time you see a modulus bracket on a high-stakes paper, will you react like a panicked rookie? Or will you execute the cold, analytical logic of a lead detective? Case closed.